Hello class, my name is Greg Ramlagan and today I will be going through Lecture 6 problem set for you through your Chem 10 course with Professor Wynn. First of all, Lecture 6 is all about getting to know your periodic table and getting more attuned to knowing the different groups that certain elements belong to, and also figuring out which kinds of elements are nonmetals, metalloids, and metals, and certain groups that are called different metals, such as your alkali groups, your alkaline groups, your transition metals, your noble gases, your halogens. So let's begin with problem 1. Alright class, so the name game. There are 118 known elements, 88 of which exist in nature. In order for us to talk about these elements, we give them names and chemical symbols, 1 or 2 letter abbreviations. Be familiar with the names and symbols of some of the most common elements. You could refer to table 4.2 if you must. Give corresponding names or symbols of the following elements. So, question 1a, AU. So, how can we figure this out? For one, you will either be given a periodic table or with your lab book that you get signed by Professor Wynn will give you a periodic table that's not fully informative, but it gives you some of the chemical symbols, and there's other ones that he will provide throughout the course that will help you understand more of the different names. So this one's from the chemical lab book. It's kind of hard to tell because if you could see here, it doesn't really explain anything much besides the mass number, the abbreviations of what every element is. So there's another one that you could find either online or one that you print out or one that he hands you in class, and that one looks like this here. So first question asks for AU. Where on the chart can you find AU? Simple, just look around and you'll see that AU is right here, number 79, which is gold. So question 1, all you need to do is just write in gold. It's not asking more than that. So second one is silver, the abbreviation for silver. You'll find it here in the transition metals, right here, AG, which all you need to do is abbreviate AG. PB for question E. Alright class, for question 1, the name game. Question 1a asks us to find the corresponding names or the symbols of the elements. So the first one asks for AU, which on the periodic table is gold, number 79, right there. So you would write that down for question A, and you'll write gold. Question B, which is oxygen, is very simple. One of the easiest ones on the periodic table. It is O, number 8. So you just go ahead and put O. C asks for silver, which is AG, and you can find it number 47 right there. So you just put AG on your paper. D asks for potassium, and potassium is a little weird. They don't go by P, they actually go by K. It's right here, number 19. So go ahead and just put K. PB. PB, you'll find it right. Sometimes it gets a little hard to find these things. PB, lead, number 82. So go ahead and write in lead. F is Na, which most people would be like, what the heck is Na? It is sodium, so that's number 11. So go ahead and write in sodium for 1F. And this is a really important one to remember. You'll use it a lot in class. 1G, Cl. It is chlorine, number 17. Another one you'll be using consistently in the class. So chlorine. And finally, for question 1H, SN number 50, which is tin. Go ahead and write in tin. And there goes number 1. For anyone having trouble, just reference your periodic table if you could print one out, or one that's more detailed compared to the one in the lab book. I encourage it, especially if it lays out the certain group numbers and also you highlighting certain areas that are not highlighted in it to help you remember which one are alkali, alkaline, halogens, noble gases, transition metals. Now let's move on to number 2. Number 2, chemical Legos. Each element is a pure substance that is unique and cannot be broken down into simpler substances. On the other hand, different elements combine to give rise to an infinite variety of substances known as compounds. Name the elements that are represented by the chemical symbols in each of the following compounds. The smaller number, known as a subscript, indicates the ratio of the different elements. More about these subscripts, you could actually read it in chapter 6 as well, but subscripts are the small little numbers at the end here, the ones that people don't really know what the heck they're about. That's a subscript. How many the tiny little carries in each one of the elements here. So read more on that. It'll help you on the long run. Lecture 6 is easier to remember, so let's go through this. So table salt. You can see up here we wrote down some of the things it already has. So NaCl. So it has sodium chlorine. So go ahead and just write that in. So it has sodium, comma, chlorine. You'll get more in depth of what it would be called later on, but it's just asking to give us each one of the elements, what it carries. So here we have C, which is carbon. You can find that on the periodic table, which is number 6, comma, H, which is hydrogen, NO, so you would have to do these separately, which N is nitrogen, and O is oxygen, one that we already did. Pretty easy, right? Not too hard. Now, I'm going in opposite fashion, but I always like going left to right. But B, coral. CaCO3. You already know some of these. Ca, calcium, carbon, and oxygen. Last one, amoxicillin, a little bigger one. Don't get scared about it. It's just asking for a very simple explanation of what's inside. So C, carbon, hydrogen, nitrogen, oxygen, and S, which on the periodic table is sulfur, number 16. All right, that is question number 2. After this explanation, you should try doing this on your own. One of the biggest things is actually redoing it over and over again to help you remember the chemical names, just in case in one of the tests he asked for it. So remember what you do here, remember each one of the chemical symbols, and then let's move on to number 3. Problem number 3, elemental cliques. We got to group the different elements into their actual groups and see if they have any extra special names, such as alkali, alkaline, and halogens and noble gases. So the first one I answered, which was calcium, which is group 2A alkaline. So group 2A on the periodic table is on the top left, if you can see it on the very top. So group 2A, and calcium is number 20. And that one is an alkaline earth metal. So that's why I put as the answer, group 2A, alkaline. And it's going to ask for you to look for zinc, zinc is number 30 in group 2B. So in group 2B, that is a variant compound as well. It's in the grouping of like the transition metals. So one of the two things you could put, which I would put just to be more specific, is the variant compound, just to keep it away from the other transition metals. So zinc, we put group 2B, variant compound. Now, next one is potassium, and potassium is in group 1A. So group 1A, and it is a alkali. So an alkali metal. Next one is helium, which is G, and helium is right as group number 8A. It's on the very top of group 8A on the very right. So group 8A, and it is a noble gas. The next one is carbon. Carbon is group 4A, right there. So you label group 4A, and it is in what group? Kind of confusing, right? But remember, you gotta write things down so it has no common name. So one thing that you could do is just write group 4A, no common name. Common name. Now, another thing you can do is just put nonmetals, but if you want to be more specific, no common name is fine. So D is iodine. Iodine is I, which is number 53 on the periodic table. Right there next to xenon. So that is group number 7A. 7A. And it is a halogen. Halogen. The next one is magnesium, and that was number 12 on the group 2A on the left side. Number 12. So group 12, group 2A, and it is a alkaline. The next one is iron, H. So iron is number 26, and that one is in the middle part, which is a transition metal. Or you could put just transition element or transition metals, one of the two. So it is weird because one thing that we were taught was like these three here are all group 8. So it goes, all of them are group 8B, but it goes 8, 9, 10. So this one could be group 8, 8B. So group 8, 8B, and that one is a transition or elemental element. So transition metal or transition element. Now, all done with number 3. Hopefully you understood that. Let's move on to number 4. Alright, number 4. To metal or non-metal, that is the question. The elements can also be grouped into metals, non-metals, or metalloids. Metals are often shiny, solid, at room temperature, ductile, malleable, and can even conduct electricity and heat. Non-metals cannot. Metalloids are in between the two groups, so they are a little bit like metals and not like non-metals. Identify the following essential elements in your body as metal, non-metal, or metalloid. So the first one, magnesium. Well, on this chart here, it kind of gives us a easy way to look at it. Right here on the right, it tells us which color is nonmetals, metals, and metalloids. So it's asking for magnesium. Magnesium is number 12 on the very left, and that is a metal. So go ahead and write that down, metal. Manganese, one that people confuse a lot, which is number 25 in the middle of the periodic table, close to the middle next to iron. And that one is a metal as well. Silicon. Silicon, huh? Or silicone. That one is a metalloid. It is number 14 on the periodic table. So go ahead and write metalloid. D, aluminum. Aluminum is number 13 right next to silicone, and that one is a metal. Phosphorus. Now, phosphorus is P, number 15. So it's in the yellow, so it is a non-metal. So go ahead and write non-metal. And hydrogen. Is it a metal or a non-metal? It's on the left side of the chart, right? It's not on the right. Well, some of the things I read was like it could be both, but in this case, since it is yellow, we're going to put it as non-metal. There we go. Pretty simple. Just setting up what you do as a non-metal metalloid. And just label each. Now let's get started with number 5. Number 5, it might seem a little bit confusing, but in all reality, it's pretty simple. So, the atom, the story of the comeback kid. Early Greek philosophers have proposed the idea of an atom as the smallest building block of life that cannot be divided into simpler substances. In fact, the word atom is Greek for not able to cut. But without the scientific method, these ideas were not supported and so faded away as prominent philosophers favored other ideas. It took more than 2,000 years until the 1600s that scientists began to revisit the atom. In 1808, John Dalton proposed that we now know as the atomic theory. At the same time, other scientists like J.J. Thomson and Ernest Rutherford performed experiments to describe the features and components of the atom. First, don't look at your notes. Draw the rough sketch of an atom. Be sure to label the nucleus, electrons, protons, and neutrons. So, how can we do this as a rough sketch? Well, first of all, during lecture or any of the play pause it videos, you know that a nucleus, everything for these to hold, protons and neutrons, you need to have something to hold it, which is like a house, like a protective bubble, which is the nucleus. So go ahead and just draw a circle. Right? Not the best circle, but it's a good enough circle. Rough drawing. Now, nucleuses are composed of protons and neutrons. So protons and neutrons. So go ahead and put the proton in. And go ahead and put a neutron in. Okay, getting there. Now, electrons. That's the outer core of it. So you got an electron, and it surrounds the nucleus. A charge. So it wraps around. Alright, so class. Video cut out too quick, but you got the rough sketch of it, of how it works, how an atom works. So you got your protons, your neutrons, inside of a nucleus shell, and you got an electron charge circulating around. There's a rough sketch. Looks like there's more electrons, more protons, neutrons inside. But you could label them as well to make it easier. So line them up as neutron, proton. You got your casing, which is the nucleus. Your electron on the outside. Bam. Right, let's move on to the next. What is in an atom? All atoms of an element have the same number of protons and electrons. So that's an important thing to remember. They have the same number of protons and electrons. Now, but not necessarily the same number of neutrons. Isotopes are atoms of the same element that differ in the number of neutrons, since the mass of an atom is the sum of protons and neutrons. Isotopes also differ in their mass number. There are many ways to express the identity of an isotope. The chart below shows how connected these values are to each other. You can fill in all the blanks with only one or two pieces of information. Complete the following table for an electrically neutral atom. So this chart here, you're going to be like, what the heck is this? What do we have to do? It's actually not that hard. So I had a difficult time at first trying to figure out how to calculate this. But in all general sense, the first sentence of the question gives you majority of the answers here. And knowing that the neutrons are always different, well, how do you figure that out? Well, a good way to remember is that the atomic number, the number of protons, and the number of electrons are the same, right? So how do you get the number of neutrons then? Well, you gotta minus the atomic number from the mass number, and you'll get your number of neutrons. So let's start off with the first one. So hydrogen. So symbol H, okay. Atomic number 1, mass number 1, number of protons 1, number of neutrons. 1 minus 1, got 0 neutrons. Number of electrons. Well, didn't it just say protons and electrons are the same? So 1. Now nitrogen. You have a periodic table, right? So symbol N. Atomic number 7. Cool. It's the same, right? So 7. Great. 7 minus 14, or 14 minus 7, you could say. 7. Same number, right? 7. It's not that difficult. It's pretty easy once you get a hang of it. I mean, majority of the time, these will solve themselves once you fill in one of the blanks. So the next one, well, it has no element name or no symbol or even an atomic number. How the heck are we going to figure this out? Well, let's figure it out. Since the atomic number is the same as the proton number and the electron number, right? Why not go back and figure it out then? Electron is 8, proton is 8. Shouldn't this one be 8? Because 16 minus 8 gives you 8 neutrons. So, let's try it. Number 8. What's number 8? Oxygen. So, O and oxygen. Pretty simple, right? Already solved one for you. Chlorine kind of gives you a hint of how to do it. So the next one. Now we don't have the symbol, the atomic number, or the number of protons. But you do have the number of electrons, which is 26. Wouldn't it be the same? Right? 26. What is number 26? Number 26 is iron. So you do Fe and iron. Now let's finish the last one. Gold gives you the element name, nothing else. Number of neutrons, cool. Let's figure this out. What is the symbol for gold? Look at the periodic table and gold. Ow, you just solved that one not too long ago, right? So you have Ag, silver, and number 79 AU is gold. And you could also look at your other periodic table to make sure, which AG, silver, AU, gold. So since you got that handled, go ahead and write AU, and that was number 79. Okay, and remember, it's the same, right, as the protons. So 79, electrons, 79. And how do we do this then? How do we figure this out? Very, very simple. So 197, it's the mass number. We're in the periodic table of the mass number. You round it to the nearest hundreds. So 97, since it's above the 5, that goes and changes this to 197. So that is your answer. 197. And 197 minus 79 gives you 118. You could double check it. You could check. Pretty sure it's right. Now, let's move on to the next. Number 7. The different ways to write isotope. Normally, when we want to refer to a particular isotope, there are about 3 main written ways. What they have in common is that they must mention the mass number, the element symbol, and what are the number of protons, neutrons, and electrons in the following electrically neutral isotopes. So it kind of gives you some hints already. So P is phosphorus, right? So phosphorus is number 15 on the periodic table. You can look for that. And that's 15 as a number. So 15 as a number, and remember on the chart, atomic number equals the amount of protons, right? And on the chart, it's 15. So, you're right, 15 for the protons. And protons and electrons are the same, right? So it's 15. Perfect. Now we gotta get it to add to 32. What can we add to get it to 32? Just simply minus 32 minus 15, give you 17. Now, B, 18.8, and O, well, gives us that it's oxygen. Cool. So if it's oxygen, it's number 8. We solved that earlier. So go ahead and write 8, and it's the same as electrons, so 8 neutrons. If you can't remember, you did it up here. Neutrons, right there, 8. Boom. Actually 10, I'm sorry. So here, yeah, 10, I'm sorry. You actually minus this to this, it gives you 10. There we go. 8, 16. Messed up a little on B. Sorry if you can't read that, that's a number 8. But let me just rewrite it real quick so you can actually look at. So protons is 8, neutrons is 8, electrons are 8. Now the next one for C. Cobalt. CO, number 27 on the periodic table. Right there. So that one is, as you remember, number 27, you could use it as the same for the protons. So 27, boom. And then you do 27 electrons. And what can we do to get the neutrons? Well, you got one choice, which is minusing the 60 to 27, which will give you the number 33. Doing the math, that gives you 60, which is a total equivalence of the mass number there. So hopefully this has helped. I made it a little bit easier for you. I know I struggled with this chapter just a little bit at first because I'm not into chemistry as much, but understanding it and making it easier for myself has helped me drastically. So hopefully it helps you too. Hope you enjoyed this video, and good luck with your Chem 10 class. Bye.